If both x plus 2 and x minus half, sorry, x minus 2 and x minus half are the factors of this particular expression, show that p is equal to r. So what is that we have to do over here? What theorem we have to use? Since they're talking about factor, yes, we have to make use of factor theorem, which tells that the remainder will be 0 if the given expression is a factor of the other expression. How will you find the remainder? So using the remainder theorem, which tells us to find the 0 of the denominator, right, of the divisor, and then substitute it in your expression p of x, and that will give us the remainder. So in this case, since it's a factor, it has to be equal to, yes, 0. Okay. So first thing first, let's figure out what is given. So in terms of let, I'll call it as u of x be equal to x minus 2 and v of x is equal to x minus half. Okay. So we have u and v. Next is p of x is equal to p of x square, or let me call it as y of x plus 5x plus r. Okay, all this is given, and u of x and v of x is a factor of, and v of x is a factor of y of x. Okay guys, this is all the things that is given. We have to prove. So this is to prove question. P is equal to r. Now the proof. Okay, so how will we go about doing this? Simple. Since we are talking about remainder and factors and all of that, first we'll talk about finding the zeros of u of x and v of x. So we'll begin with 0 of u of x. For that, again I'll start off with let t be its 0. Okay, that is u of x when equated to t should be equal to 0. So t minus half will be equal to 0. So t is equal to 2. Okay, and also we'll find the 0 of v of x. So in this case, we have again let t be its 0, and we have v of x when it equated to t will be equal to 0. So we have x minus half being equated to 0. So x will be equal to half, right? Simple and straightforward. Now these two values, oh sorry, this is t by the way. So this set of values, when we put it over here, the output should be 0, is it not? So as per factor theorem, the remainder when I substitute x is equal to 2 in y of x will be equal to 0, is it not? So p into 2 square plus 2 into 5 or 5 into 2 plus r is equal to 0. So this will be what? This is 4p plus 10 plus r is equal to 0. Okay, that's your equation 1. We'll call that later. Then u of x when equated to half should also be equal to 0. So we have negative half square into p plus 5 times of negative 2. Let me write it properly. Plus r is equal to 0. So negative half square is what? 1/4. So p by 4. So this will be equal to p by 4, and this is minus half and 5 by 2 plus r is equal to 0. So for ease of working, we'll multiply with 4. Why? 4 is the LCM over here. It's better to simplify this a bit. So 4p by 4 minus 5 into 4 by 2 plus 4r is equal to 0 into 4. So we have 4 and 4 getting cancelled. So p minus, this is 1s are 2s are 10 plus 4r is equal to 0. Since equation 1 and 2 both are equal to 0, what can we tell? From 1 and 2, right? 4p plus 10 plus r is equal to p minus 10 plus 4r. Okay guys, so let me just check once again. Sorry, this is not negative, this is positive. I thought so, because we should not be getting 10 over here. Yeah, okay, so this would be your expression and so on and so forth. So we have 10 both the sides, that is common. So okay, let me do this. Let me transpose this and this to the right hand side and this to the left hand side. So 4p minus p is equal to 10 plus 4r. This 10 will be minus 10 and minus r. And so we have, this is 3p, right, because this is 1, and plus 10 minus 10 will get cancelled, and this is again 3r. So if I divide 3 both the sides, what happens? Yes, p will be equal to r. That's it. Okay, so this is your answer. Again, the funda is quite same, but there is an extra bit wherein you have to equate equation 1 and equation 2. That's the only extra bit, because both are equal to 0, is it not? Both these are equal to 0, right? So obviously this particular expression should be equal to this particular expression. That's it, nothing fancy I'm doing. It's a simple and straightforward thing. So when we solve it, we'll get the required thing, and hence proved. Okay, so yeah, now pause and have a look at the answer.